Hello lovelies, in this video I'm going to take you through my OCR gateway, my predicted paper for Chemistry Paper 1, the Separate Science Foundation in 2023. What a mouthful. Now, if you haven't had a go at this paper already, what I want you to do is to look at the question, look at me explain any clues the examiners or I have left you in the question. Play the video after you've had a go at the answers yourself, and then we can work through the answers together. When I'm going through these papers, I'm going to use a little bit of colour coding. So anything that I do in blue is going to be an exam skill, command word, technique, a clue that the examiner is leaving you that I want you to pay attention to. Anything that is in these couple of different shades of purple is going to be background knowledge, show the science bit, recall, stuff that you should know from class. And then anything that I do in pink is going to be the actual answer. So what I would actually write in the exam. So starting off with our multiple choice questions. Now, when we're looking at these, I'm going to show you two ways to do it. I'm going to show you the long way to do it. So that if a question like this comes up in the main part of the paper, you know how to do the long way. And then I'm going to show you the shortcut way, if there is a shortcut way, so we can answer these questions really quickly. So what I'm going to do here is just draw you a little table so we can do the first question on a little line. What do we call the process by which a substance changes state from a liquid to a solid? So if we're going from a solid to a liquid, that is melting. You can always draw yourself little kind of like aid memoirs during the exam to help you. From a liquid to a gas, it is boiling. If we're going to go from a gas to a liquid, it is condensing. And if we're going from a liquid to a solid, it is freezing. So when we're actually looking at the question, what we need to be looking for is going from a liquid to a solid. So we can see that the answer I've drawn on my little diagram is freezing. Which of these statements about metals is not true? Now, these questions trip students up all of the time because what we're looking for is they're not true, but lots of students will forget that bit. They will miss that part of the question. And they'll read the first point, read point A, realise it is true, and then just put A down, not fully read everything. So what I want you to do with these is to not tick and cross, because these could be mistaken as actually working out what the right answer is, but just write next to it T or F, true or false. So they can conduct electricity because they have delocalized electron. That is true. They are malleable because the cations are arranged in layers. That is true. They have relatively high melting points because of the strong force of attraction. That is true. They are poor conductors of heat due to delocalized electrons' inability to carry energy. That is false. Metals are good conductors. So the answer is D. What process of separation is best used to separate sand from water? So what you can do in an exam is make yourself some little notes. So here is sand, which is a solid, and we're separating from water, which is a liquid. So we're separating solid from a liquid. So which of these do we know can do that? Well, chromatography is paper, separating things with paper. Crystallization is making salts. Filtration is separating a solid from a liquid. So that is our answer. And then just to finish it off, fractional distillation is separating crude oil out. So C here is our answer. Describe the energy of reactants compared to the products in an endothermic reaction. So you can draw yourself a little sketch in the exam, that's absolutely fine. So here is the reaction profile for an endothermic reaction that I would expect that you do know. We've got reaction on the bottom, we've got energy up the side. Now this is just a sketch to help us remember, so it doesn't have to be super neat or detailed or anything like that. But for an endothermic reaction, we have reactants at the bottom and we have products at the top. The reactants here are going to have less energy, products are going to have more energy, which means that D is going to be our answer. These two are just a couple of recall questions. Which is the only substance with a giant covalent structure that can conduct electricity? That is graphite. And what is graphite? Graphene, which is one layer of graphite made from, they're made from carbon. Describe the relationship between the purity of a substance and the melting point range. So when we're doing this, we can now go through using our highlighters, highlight the important things, pick out which bits are interesting to us. So purity has no impact on the melting point range. We know that's not the right answer, so we can cross that one out. And then after this is just a recall question, and B is the correct answer. Within paper chromatography, what is the mobile phase? So I'd make myself a little note there. That is the moving phase. Pencil, paper, they can't move. The solvent can. What process is used during distillation? Distillation, if you remember, probably a demo that you did for this, we're boiling things. Which element has the following electronic structure? So from this, I'm just going to make myself some notes. It has 2 shells. That means it's going to be in 2. It has 3 electrons on the outer shell. That means it's going to be in group 3. And it has 5 electrons in total. That means the atomic number is going to be 5. So there's lots of information there. We can then go to our periodic table and look up what it's supposed to be. So here is period 2. Here is group 3, so it has 3 electrons on the outer shell. Now you can go across and down and find out what that is. But then the last bit of information is that it has 5 electrons in total, so we're looking for a thing that has the atomic number of 5. All of that information together gives us boron, which is D. And we've already answered this in our notes. What does the group tell you about the atom of an element? It tells you the number of electrons in the outer shell. So the answer is D. The atomic radius of an atom of argon is 0.098 nanometers. What is this in standard form? Now when we go in standard form, we want number point number times 10 to the minus, and we're going to move that decimal place 2 spaces, so it's the -2. So B is our answer. What is the formula used to calculate the RF value? And this is just a recall question, so you should need to remember that the answer is C. Which of these statements about chlorine is not true? So we can go to our periodic table, we can find chlorine, circle chlorine, get your highlighters out, get your pens out. So pick chlorine out and then have a look at it. It is in group 7, so that means it has 7 electrons on its outer shell. It is in period 3, so that means it has 3 electron shells. And then when we look at the atomic number, that is 17, so it has 17 electrons in total. Now with these not questions, people will forget there's a not in there and just pick the first right answer, which is A, but that is not, because that is true. We're looking for the one that is false. So you can see I've just written true and false to help me work it out. Calculate the relative formula mass of calcium carbonate. So we need to look up the mass numbers. The mass of calcium is 40, the mass of carbon is 12, the mass of oxygen is 16, and we have 3 of those. Pop that in your calculator and you'll get 100, so C is the answer. Moving on to section B now, so our longer answer questions. Atoms are made up from subatomic particles, electrons, neutrons, and protons. Describe the structure of the atom by matching the subatomic particle to its location in the atom. Draw 3 lines only. So here I am doing a little sketch over on the left hand side. We have our protons in the middle there. We also have our neutrons. And then on the outside we have our electrons in shells. This bit in the middle here where the protons and the neutrons are gathered, this is the nucleus. And the electrons are on the outer shells on the outside. So the lines that we need to draw, and we do just need to draw 3 very clear lines here, no more, no less. If we draw 2 lines, we're limiting ourselves to 2 marks. If we draw 4 lines, then we're not clearly showing the examiner we know what we're doing, so that is going to be 0 marks. On the other hand, if you don't even guess and you draw 0 lines, you're also limiting yourself to 0 marks, so please at least guess. Protons and neutrons are in the nucleus and electrons are in the shells. State the charge of the subatomic particles using words from the box. Protons are positive, neutrons are neutral, so those ones are nice and easy to remember because it's the same letter, whereas electrons are negative. This is the symbol for sodium from the periodic table. Calculate the number of protons, neutrons, and electrons in an atom of sodium. So we need to clearly lay out the number of protons, neutrons, and electrons. Now with these numbers, the location doesn't matter. We're just looking for the larger number and the smaller number of the 2. So the smaller number of the 2 is going to be the atomic number. This is equal to the number of protons and it's equal to the number of electrons in an atom. The other number, that is the larger number of the two, this is the mass number. This is equal to the number of protons plus the number of neutrons. So if you want to find the number of neutrons, we can do mass number minus atomic number. So from all of this information, we can calculate the number of protons, neutrons, and electrons. Protons and electrons are the same as the atomic number, but I'm going to lay it out clearly to show the examiner that I know that. So 11 protons, 11 electrons, and then when we come to neutrons, I'm going to do the calculation again to show the examiner. So 23 minus 11 equals 12 neutrons. State who suggested the location of the electrons. So that is the location of the electrons, not who discovered the electrons. That is completely different. It was Niels Bohr that did this. State who said all matter was made up of small particles called atoms. So this is going quite a long way back now. The person that did that was Dalton. Rutherford wanted to study the plum pudding model of an atom by running an alpha scattering experiment. Describe what Rutherford found and explain how this changed the model of the atom. So the plum pudding model of the atom, we're looking at the alpha scattering experiment. We have gold foil and we fired alpha particles at it. Some of them went straight through, which was unexpected. Some of them were partially deflected and some were fully deflected. And that's what we can say in our answer. Some alpha particles went straight through and some were partially deflected, suggesting that most of the mass is in the centre of the atom, and this is the nucleus. Here is our mark scheme. You can see there's nothing too different here. We have to stick to what we know for this one. Sulfuric acid is a common solution used in the manufacture of fertilizer. Salts suggest a pH for sulfuric acid. So this is not a recall question here. They do not expect you to know exactly what this is. A suggest question means use your common sense and then mix it with the stuff that you know from chemistry to come up with a sensible answer. So when we're looking at pH, there are some numbers that you need to know. You need to know 1, which is acidic. You need to know 7, which is in the middle, that is neutral. And then you need to know 14, which is the other end, which is alkaline. So if we are looking for a pH for sulfuric acid, we're going to be on the acidic side of things. So 7 wouldn't be a good answer because that's neutral, but it's going to be somewhere in this range. So I'm going to give the answer of 2. You could have 3, 4. How could the pH of sulfuric acid be determined experimentally? So how could we actually work it out? There are a few different ways you could do this. We'll look at those in the mark scheme, but I'm just going to say a pH probe here. Describe the general reaction by selecting the name of the reaction. Tick one box only. So again, if you tick 2 boxes, you'll get no marks because you're clearly not demonstrating to the examiner you know what you're talking about. If you tick no boxes, you're not getting any marks because you haven't put any effort in. So we need to tick just 1 box only. So when we look at these, displacement reaction, that is something to do with halogens. An exothermic reaction, that's something that gets hot. So the only answer we're left over, and hopefully you do recall this, is a neutralization reaction. Give the equation for the reaction between ions produced from aqueous acid, H+, and the ions produced from aqueous alkali, OH-. So this and the next question is just an interpreting question. If we have H+ and OH-, we can add those together and we will get water in a neutralization reaction. Zinc metal reacts with sulfuric acid to give 2 products, zinc sulfate and hydrogen gas. Write the balanced chemical equation for this reaction. So this is just, can you read the question and interpret it? So zinc metal, Zn, reacts with sulfuric acid, H2SO4, to give 2 products, that's the arrow, zinc sulfate, ZnSO4, plus hydrogen gas, H2. All you had to do here, I know it looks scary, but all you had to do here was just read the question and write out what it told you in an equation. A student tried the same reaction but placed zinc for magnesium metal. Suggest the products from the action between magnesium and sulfuric acid. So in the past reaction on the other page, we had zinc plus sulfuric acid, and then that gave us 2 products, like it said in the question. It gave us zinc sulfate and it gave us hydrogen gas. Now, if we have just replaced zinc for magnesium, all we need to do is, well, just replace it. So instead of having zinc, we have magnesium. And instead of having zinc sulfate, we are going to have magnesium sulfate. And then the second product hasn't changed. So what we are going to have is magnesium sulfate plus hydrogen gas. A student wanted to look at the reaction between a strip of zinc metal and sulfuric acid. They set up the equipment as shown in the image below in the method. Place a conical flask on a mass balance. Measure out 20 centimetres cubed sulfuric acid and add it to the conical flask. Measure 2 centimetres strip of zinc ribbon. Add the ribbon to the conical flask. Record the initial mass. Record the mass every 30 seconds. Repeat to obtain 3 sets of results. And then we have our image. Calculate the mean value for change in mass at 90 seconds. Now, whenever you see this in the exam, this is kind of a clue to what the examiners want you to do. They want you to look for the anomalous result. So here I'm going to get my highlighter out, and I'm actually going to highlight the row that we're looking at to make it a little bit more obvious to me so I don't accidentally confuse different rows, look at wrong numbers. And then I'm going to circle the anomalous result, and that's the one that I'm leaving out. So what I want to do is 29 plus 31 divided by 2 gives us 30. Use the image to help you describe and explain the change in mass. Now, we need the equation for this as well, because hydrogen gas is one of the products. Now, if you've seen this, if you've ever seen a bit of metal being dropped into acid, then you'll see bubbles. Bubbles will then float away, they will disappear, so the mass will go down because gas is lost. Identify a control variable and state how they measured it. Now, there are loads here, and the best thing you can do is go to the method and read it carefully to try and find a control variable. But for 2 marks, I want what it was and how it was controlled. There are lots you can pick from for this, and we'll look at those in the mark scheme, but I'm going to go for the volume of acid and measuring it with a measuring cylinder. The table shows loss of mass. Explain why this is not what the student measured. Because a balance, what it's sitting on, measures the actual mass. The change in mass is something that has to be calculated afterwards. Sketch a graph for mean loss of mass versus time. So when we are sketching a graph, we need to just draw a rough sketch. This is not plotting the points and joining up the dots. This is not involving graph paper. So we want lines, we want labels on the axis, we want units on the axis, and then we want the rough shape of the line. So just looking at the table, it goes up and then it levels off. So we're going to have time, and that is going to be in seconds. And then on our y-axis, we're going to have change in mass, and that is in grams. They noticed the conical flask got warmer as the reaction took place. Describe what this implies about the overall energy change and state the type of reaction. So this is an exothermic reaction. An exothermic reaction gets hot. Heat is energy. Energy is being given out. The reaction profile for the reaction shown below. Identify what the labels A to C represent. So we have progress of reaction, we have energy change. So A is going to be the reactants because that's what we start with. And if A is the reactants, that means C is the product. B in the middle there, that gap is the activation energy. And C is the products. Learn this shape and learn this shape for an exothermic reaction. For an endothermic reaction, A would be lower than C. Here are our answer for this. You can see for some of them, it's very, very prescriptive, but for the control variables, there's lots of different things you could write here. Again, lots more control variables, but for the products, the reactants, is very prescriptive. A student carried out electrolysis solution of copper chloride. Give the expected products at each electrode. So we have the negative electrode and the positive electrode. And you can see there are some massive clues on the diagram here. On the negative electrode, we can see a solid build-up, and on the positive electrode there are bubbles, which suggest that there is a gas being released. So at the negative electrode, we are going to have copper building up, and at the positive electrode, we are going to have chlorine. One of the products was chlorine gas. State how you could determine the identity of this gas. So this is testing for different ions. So what we are looking for is bleaching litmus paper here. State the role of the power pack in this experiment. Now we need the power pack, it needs to be turned on so the electricity can flow, or you could say something like to complete the circuit so that there was current to flow. No bubbles of gas were seen, suggests a modification that would allow us to show the circuit had been set up correctly. So here is a video of a simple electrolysis circuit, not exactly the same one, but we can see what I've got in here is a bulb to show that the electrons are flowing, to prove that the circuit has been set up correctly. In class, you may or may not have done this with a bulb, but they are useful to check that the circuit is set up correctly. The students were told to limit the voltage on the power pack for health and safety reasons. Thinking about the products, so that is a massive clue there, thinking about the products of the reaction, explain why. Now, chlorine gas is a product. We don't want to be breathing too much of that in because it is harmful gas to breathe in. And if you're doing this at a very high voltage, lots of chlorine gas will be produced, and we don't want too much chlorine gas produced in the lab. Give the half equations for the reaction with copper ions. So that is copper 2 plus 2 electrons will give us copper. Explain why a solution used for electrolysis and not a solid substance. It is because the ions need to be free to move, and if we think about our particle models, the ions in a solid are not free to move, they are in a fixed position. So we have to have a solution or a liquid for electrolysis so that the ions can be free to move around. Here is our mark scheme, nothing too different from what we've already said here, just showing you that you could have had a bulb or a voltmeter or an ammeter or something like that. Nanoparticles are very small. Compare the volume of a cube that has a side of 10 nanometers and the volume of a cube that has a side of 2 nanometers. And we are told that the volume is given by width times length times depth. So all we need to do for this question is do the big cube, the large cube first, which is 10 times 10 times 10. And that is going to give us 1,000 nanometers cubed. Units here are really, really important. And then we can do the smaller cube, which has sides of 2. So 2 times 2 times 2 is going to give us 8 nanometers cubed. And we can see that the cubes with the larger sides has a larger volume. 125 of the small cubes can sit inside the larger cube. Compare the surface area of two sets of the same cube. A surface area has a side. The surface area of a side is length times width, and a cube has 6 sides. This is a clue. So if we think of our cube here, and each width, length, and depth is going to be the same, if we unfold that in our minds, we can see the plan of the cube with the width times length being the same, and then we're going to have 6 faces. We're also told in the question that one large cube is equal to 125 small cubes. So while the maths in this question is quite simple, working out which numbers we need to use. So to work out the surface area of a cube, we have one large cube times 10 the width times 10 the length times 6 faces, which will give us 600 nanometers squared as the surface area. For the small cubes, we know that we have 125 small cubes. Their width is 2, their length is 2, and again they have 6 faces, which will give us 3,000 nanometers squared, which is a much larger surface area. Comment on the surface area to volume ratio of the cubes. Now this is a 1-mark question, so you could, if you know the answer, just write down the answer, or you could work it out. So it says surface area to volume ratio, so we put surface area on the top, volume on the bottom, and that will give us the ratio. So for the large cubes, the surface area was 600 and the volume was 1000, which would give us a surface area to volume ratio of 0.6. And for the small cubes, the surface area was 3000 and the volume was 8, which would give us a surface area to volume ratio of 375. And there are no units here because this is a ratio. So if you don't know the answer, you could work out the answer from the information given in the question. However, this is true for all nanoparticles and is the reason that nano is so useful. The smaller cubes will have a larger surface area to volume ratio. One application for nanoparticles is sun cream. Suggest 2 other applications. This is a 2-mark question. Suggest, so we're just going to be writing down 2 really simple things that you can remember. We don't need to write sentences for this because there is no point to writing sentences for this. That's just a waste of time. Just 2 simple words. So you could have medicine, you could have cosmetics, you could have deodorant, you could have electronics. There are lots of different things. And we will see on the mark scheme that you pick any 2 things from the list. Titanium dioxide is used in sunscreens as it is very effective at reflecting UV rays away from skin and preventing damage. So we know that it's good at reflecting UV. The titanium dioxide is partially responsible for the white colour and thick consistency of sun creams, and these can sometimes leave a thin film over the skin as they can't easily penetrate. These are all clues in the question. Modern sun creams use nanoparticles of titanium dioxide that resolve these issues. Discuss the advantages and disadvantages of using nanoparticles. And this is for 5 marks. So it's probably not going to be hierarchical level response marking. We're probably just looking for 2 paragraphs in an exam. You can guess the sorts of things the examiners are looking for based on the number of marks. So if you see something that is 5 marks, you can probably just write 2 simple paragraphs. Now, titanium dioxide is nanoparticles, but maybe in a new context that you haven't seen before. However, there is nothing in this question that you can't do because the chemistry is exactly the same. And the question has given us loads and loads of clues. It's told us that modern sunscreens resolve these issues. So whereas the old sunscreens couldn't penetrate the skin, nanoparticles can penetrate the skin. Whereas the old sunscreen had thick consistency, the nanoparticles are going to have a better consistency. Whereas the old sunscreen had the white colour, and you may be familiar with cricketers that have strips of white on their nose or on their cheeks. That's the really thick sunscreen. The new one will not have this white colour because it can be more easily absorbed into the skin. So then we have all of this information, we've done all of this planning. We can now start to write our answer. Nanoparticles of zinc oxide could rub into skin easier. We got this information from the question. Without leaving a white colour on the skin. Again, we got this information from the question. Nanoparticles can get deeper into the skin. We got this information from the question. We're not remembering or recalling anything here. However, keyword to indicate to the examiners that we are moving on to the second part of the question and talking about disadvantages. And this is where we need to think about things that aren't in the question. It might be hard to see areas of skin that are missed. So without that white, you might not get all of the skin. There are now sunscreens that actually have a blue tint to them to show you exactly which parts you've missed. And then a disadvantage that you've probably talked about in class, that the long-term effects of this are not known. So we've said 5 statements in there. The majority of them that can rub into skin without leaving white colour on the skin, and the nanoparticles can get deeper into the skin, are things that we got from the question. The fact that it might be hard to see some areas of skin that is missed is something else we probably could have worked out from the question. There's only one thing really in here that has come from our recall. This is interpreting things in a new context. Lots of advantages and disadvantages here, lots of things you could have picked from a list for this one. Ammonia has the formula NH3. Ammonia is a simple covalent compound. There are a few that you have to learn, or you should learn. The formula of ammonia is one of them. There's also oxygen, O2, water, which is H2O, carbon dioxide, CO2. Even if you can't remember them off the top of your head, being familiar with them is always nice. State the bonding seen in ammonia. This is covalent bonding, and again, we need to tick one box only. Draw the bonding seen in ammonia, and here we're going to be drawing the outer electrons only. And it is always good to find the things that we're drawing on our periodic table to help us work out the type of bonding and the electrons that we can see in this. So we have NH3. N is going to go in the middle, and then the 3 H's are going to go around the outside. Now, hydrogen is over here in group 1, and nitrogen is over in group 5. Now, hydrogen has 1 electron on the outer shell. It's in group 1, 1 electron on the outer shell. Nitrogen is in group 5, so it has 5 electrons on the outer shell. We're going to be drawing a dot and cross diagram for this, so make sure your dots can actually be seen. Teeny tiny full stop just won't be seen. So hydrogen, 1 dot, and then nitrogen, we're going to have 5 crosses. 3 of them are going to be shared and 2 of the same. So nitrogen has 5, hydrogen has 1, but there are 3 hydrogens. So 5 electrons from nitrogen, 3 times 1 lot of electrons from hydrogen makes 8, which is how many we're looking for in an outer shell, except if it's on the first group here, where we just need 2. Compare the behaviour of particles in ammonia liquid and in ammonia gas. So compare, we're looking for similarities and differences, things that are the same and things that are different. We have 4 marks here, so we can generally assume that the examiners are looking for 2 of each. So 2 similarities and 2 differences. So in a liquid or in a gas, we have particles. You can see in a liquid, there's space between them, but they're still pretty far apart. In a gas, they're very far apart and they're all over the place. A liquid has slightly different properties to a gas, and then again different to a solid. Both of them can flow. A gas can be compressed or squashed, whereas a liquid can't. A gas will have bigger spaces between the molecules or the atoms, larger spaces than seen in a liquid. A gas will take the shape of its container, as will a liquid. So there are lots of things here, and we just need to pick 4 facts to write down in our answer. So both liquids and gases can flow and take the shape of a container. However, clearly indicating to the examiners we're moving on to the other part now, gases have larger spaces between the atoms and can be compressed, whereas liquids cannot. Ammonia is a small molecule that is a liquid at -35 and a gas at -30 degrees C. When ammonia boils, bonds break and it turns from a liquid to a gas. Describe which bonds are broken and why, and which ones are not broken and why. What it looks like is a describe. And this is 4 marks. It's asked us to do 4 things. Which one's broken, why they're broken, which ones are not broken, and why they're not broken. So inside an ammonia molecule, we have strong covalent bonds. These are the intramolecular bonds. Between ammonia molecules, when it is liquid, we have another attraction, but this is a weaker intermolecular bond. So we can say the strong covalent intramolecular bonds are not broken. And as we move from liquid ammonia to gas ammonia, it's still NH3. There's no change in formula. So those strong covalent bonds that attach the nitrogen to the hydrogen are not the ones that are broken. It is the weaker intermolecular bonds between molecules that are broken, as they require less energy to. Covalent bonding is always something that's really, really worth practicing because it comes up a lot. And then for the similarities and differences, there were lots of choice. But for the last part, your spelling of the words needs to be very, very clear. Ouch! This is why in some videos I'll explain scratches.